Hello, hello, hello. Okay, I think audio is working this time, so that's an improvement. How's everybody doing tonight? Cedar, welcome back to the stream. It's been a while. Good to have you here. I think you'll probably enjoy seeing how the, oh, there's a tripod down there. Seeing how this scope is wired. So yeah, I probably should get my iPad out because I think we're gonna be doing that again. So grab the iPad. So basically, we're going to keep going through our power distribution on the scope tonight. We got it pretty opened up now, although we might actually spin it around a little bit more to kind of get to the other side where there's some more power distribution going on. And yeah, we're making a drawing of it as we do because I like to know where the AC is at a minimum. Like I can do a lot like without knowing how like every part of a microscope is wired. But AC distribution is like, it feels different for some reason. I really, really like knowing what parts of the microscope are on or off, or anticipating how that is going to behave. So yeah, let me get this plugged in, and it should just show up on screen like it did last time. Well, it kind of just showed up on screen last time. So yeah. Okay, it's probably going to yell at me because this computer is not on IO or it's not on OS 26 yet, but that's fine. It doesn't matter. Let me make sure my recording is all working out correctly. We've got R6. That's today's date. Yeah, that looks like it's working. Cool. Boop. Okay. So where's the button I want? So that should have the iPad showing up as a source on the bottom right corner, but it's not. For some reason, I don't know why. Why you no show uppy? Why you no show uppy? That's there. Okay. The device is showing up. Okay, just deselect and select the device. That works every time. Cool. So here's what we did. Let's rearrange this a little bit, you know. Let's change it up some. How do I bring that to the front? Move to top. And then, oh, I should have just brought that forwards. Okay, let's move that to the top. Yeah. What I really should have is like the chat or something. Maybe we take like 2 seconds. We put the chat in. How hard is it to add? Should I experiment? Should I experiment with adding on-screen chat right now, or nah? We'll just leave it. Do I have another camera I can bring in here? I should have. Well, I've got the C920, although that's not really plugged in. That's been being weird. I do have that PTZ camera, but that's also been being weird. So, do I have the Logitech controls installed? Okay. Let's bring the C920 in. That'll give you all another view of what we're working on. Okay, we got the C920 connected. Oh, hey, I do have the Logitech controls installed. That's great. So let's add video capture device, add existing, C920 USB. Why didn't that work? Are you going to be weird about it too? Do we have to do this thing again? Yes, we do have to do that thing again. Wouldn't it be nice if I had like the chat to bring in or something in the bottom? Wow, of course. So now that I have the Logitech controls installed and running, the camera's completely happy, or much happier than it was previously. That's funny. Why? That's weird. That doesn't show up here. Okay. Oh, this isn't an actual window. This is something else. Okay, I see. Okay, allow access to the camera. And it can I zoom it? Hey, I can kind of zoom it. Did that just immediately crash it? No, it didn't crash it. It's just being weird. Okay. Will that zoom it out maybe? Image adjustment. That's image adjustment is what I actually care about. Turn off auto white balance. Turn off auto exposure. Cool. There we go. We got so many cameras going now. That's great. So everybody meet Cedar. Cedar's a OG stream viewer from way back in the day. Like, how many years ago was that at this point? I don't even know if I want to look at how many years ago that was. Let's look at how many years ago I started streaming. Back during my first attempt at a SEM image capture solution, which it was a passive one, like just triggering off of internal scan signals. Let's see here. I started streaming, 8 years ago. I thought it was 7 years, so that was 8 years ago. Wow, that's crazy. That was way back in the day. Okay, let's see here. It's an optical zoom on that on that optical zoom on that camera. So that looks pretty good. Maybe we'll turn exposure up just a little bit more. How do I look in this camera? Oh yeah, that looks completely reasonable. Cool. Yeah, the picture quality on the C920 can be really nice, just not when it tries to do it automatically. So where do we want this camera? Maybe we'll put this camera kind of here-ish, although maybe we want it lower. I think we want it lower. We'll do the good old. Yeah, YouTube chat latency isn't any better. Okay, let's see here. Let's no, we want that one. I was going for the wrong thing. Okay. Yeah, we'll see what it says about how to add chat real quick. It's way faster than searching. Let's see OBS docs first. I want to add the chat on screen real quick. I've been wanting that for a while. We might just get that done real quick, and then y'all can see when I see stuff. Oh, that's an interesting way of doing it. Okay, yeah, that's probably the fastest way we can possibly do that. So we'll just go pop out chat. Well, we'll find a plugin to do this actually. Oh, okay. I see. So we do a browser source. So let's add a browser source. Where's the link? Where's the chat link? Somebody has a good guide on how to do this or experience doing this, let me know. Okay. So we just copy that. Okay, that seems so sketchy. That's fine. Oh, we have a YouTube monkey. Everybody say hi to the YouTube monkey. That's fun. Okay, so that didn't work at all. So we're gonna just delete that for now. Okay, we'll figure that out off stream. Well, let's try one more time real quick. Okay. Oh, okay, that's not how that works anymore. That's Twitch chat. I don't care about Twitch chat. Huh. Okay, I mean, what I'm seeing says that that should have worked. Oh, okay, I see. It is an account issue. I don't want to fix an account issue right now. Let's just go. Let's say goodbye to the YouTube monkey. Cool. Well, shall we? So I can go over what we got so far for those of you just tuning in. This is, well, let's move the camera down here first. And then, you know what, we're going to do a little bit of floor care live on stream. I'm just going to hit this with a quick pass of the mop pad, because I'm going to be crawling around a bunch. I've been threatening to do a floor care stream for quite some time. I should do that. Maybe I'll do that when I polish this floor up next time. Surprised it's been this long, or it's taken this long to do floor care live on stream. And I'm not even breaking out any of my fancy tools for this. Okay, that should be nice and comfortable to crawl around on, and shouldn't poke myself on anything. Cool. Okay, and then last thing I'll do is I will throw this display up on my TV so that I can watch what I am doing. Nope, wrong button. Let's see here. Mirror extend to up there. That looks like it's gonna work. Why is that doing things? Okay, so now I should, it's still really thinking about it. It still hasn't done it. Why didn't it do it? Okay, one more try at that. Oh, it thinks it's doing it. Oh, because it's set to window or app. There we go. Now I can see what we're doing. Cool. Shall we? Okay. Oh, that's fun how that rotates. I like that. Okay, so power comes in here. That's that gland right there, and then it goes to our kind of hidden back there. shape turn hard enough we can see it. It goes to our power filter. From our power filter, it goes through a current transformer, and I'm not sure if that's being used for main synchronization or if that's being used for line sync yet, because we always want to start our scan at the same point on the 60 hertz waveform. And then from there, it goes to our transformer, or sorry, not a transformer, our circuit breaker, main power switch, and then that goes into our emergency off box. And I will click the button. I have to click on that camera every 30 minutes because of tax law. And let's do it. So we have a lovely note from ourselves yesterday, which is add current transformer. So let's do that now. Okay, let's just, that doesn't work. Let's do, that, delete that. And that should give us enough room to do this. Delete that, delete that, put that in. And then, yeah, how do we want to draw our transformer? Let's do, I wonder if you can do that. I think you can you do it with Magic Lantern? So CHDK is Canon Hackers Development Kit? Or camera? It's Canon, right? It's not camera. I remember how I do bring to front on this. Oh, it's fine. Okay, so that's our current transformer there. Reconnect our other conductor. There we go. Okay, so I think CHDK is for like the kind of more point and shoot class, but the 6D I know does run Magic Lantern. I don't think I have a Magic Lantern SD card in the camera right now. I might, but if I'm using the camera for like anything but just like this, I do always have Magic Lantern on it, and I should have it on it for this too. But I don't think I have a card in the camera right now. So let's tear into this box. So what's going on in here? So we've got some circuit breakers, we got some contactors, and then we got 2 power supplies. And we also have quite a bit of evidence that this thing has been worked on previously. And I have a theory as to why. And my theory as to why is that this box doesn't get any airflow and that it's just cooked some stuff before. So like we've got duct tape on some wires. I think the duct tape's just labels basically. You know, these don't match. These also don't quite exactly match. I think that this one was pre-acquisition by Eaton and this one was post-acquisition by Eaton, if I'm not mistaken. Oh, I could be wrong about that. Or Eaton sold the product line. But I feel like Eaton's the type of company that buys companies, doesn't really sell as many companies. So I'm going to guess that this was also changed out. And then our Siemens breakers here on the left, those look pretty similar. I'm looking for like a serial number or something, but they look almost identical. So I think that some of the stuff in here has been cooked just by it being very hot. So yeah, let's see here. There's quite a bit going on in here. So we're going to start just kind of with a rough sketch of this because I don't quite know where this is all going to go yet. So I'm going to make some guesses about how these contactors work. So something I don't get is what the difference. Why is there seemingly three terminals on the DC side? Are they also like switching the DC with this? Or what is going on here? So there's this other little block here on the side. It's got terminal there, terminal there. Like that makes sense as like the coil control to me. But then behind that there's another like terminal further back, which is NC, so normally closed. And then what's the label on the bottom? It's also labeled NC on the bottom. So it seems like there's also a normally closed DC relay stacked next to our contactor here. So that's interesting to me. I don't know why yet. We will explore this. And then, we've also got this button here, start. So I'm guessing there's kind of some latching logic going on in here. And so like one of these power supplies is probably like always getting power. And then that's used to kind of bootstrap this whole thing. So yeah, let's work our way through this. So we've got contactor, and we're just gonna do this like as a quick single line, or just a really quick sketch to start with, because I have a lot to figure out here. So we got two of these. And then these have another kind of terminal set on the side of them. And let's see here. So that's the positive terminal, that's the negative terminal, that's an NC, and that's an NC. And there's one of those on each of these. Are they both NC? Yeah, they are both NC. And then we've got, there's like a lot going on with these modules. We might need to pull some data sheets on these. I mean, the breakers on the left are pretty simple, so that's good. Okay, so I'm gonna use the same colored wire. So power comes in from the top, and then that also goes to the top of this breaker. Same thing for our blue wire. And then, let's see here. The output of that goes to, well, I haven't drawn the power supplies yet, so I probably should draw those next because that's where the output goes. Is it just a, okay, I see what's going on here. They're all, everything's labeled, that's lovely. Well, there's more going on in this Phoenix, on this right one. So maybe we do still need to look at that one, but man, they're using the same colored wires for positive and negative in here. Isn't that great? Let's see here. How close can we get with this lens? So I'm doing, yeah, it's my 6D. So the R6 is doing great. I've never had to restart that thing. It's the Canon 6D Mark I that I'm using as my other camera behind me. That one that I am pointing directly to, I think. And that one is the one that I've been getting the timeout issues with. So let's see here. So it's funny. So this is a positive, that's a positive output, that's a positive output, and that's a negative output, that's a negative output. And guess what? They're all blue. Isn't that great? Isn't that just great? I love that. I love that for us so much. I don't know why I'm making that as much that wide. Just gonna know where I see bad connections. We got start switch. And I've seen some on the number 2 DC supply. So, I'm doing HDMI image capture on the 6D, by the way. Okay, so we got a DC supply, and then does it like specify what line is on it? Okay, so line and neutral. God, can't do it. And then it's got, how do we want to do both rows of contacts? Because it's got like 2 rows of contacts. We'll just do this. So then black is line. Let's give ourselves some more room. I feel like we're going to want it. Blue is neutral. And then, does any of that go to our first relay, or does that kind of come from the start? So that comes from the start button, doesn't it? I love how complicated this thing is. Okay, where does our AC from our first... Okay, so well, here's what I can say. Is that this contactor here on the right, you can't see anything. Y'all gotta tell me you can't see anything. That contactor here on the right is our output. So I don't think there's any AC on this panel here. So that's convenient. There not being AC on this panel. Really convenient this panel would stay up here or something. Oh, it will. Oh, hey, look, there's labels. Look at that. Labels for things. Okay, so I can label things the same way that they've got it labeled. So of course A2 though has a much different pin arrangement, and it doesn't have the pins labeled either. So it's like I can't really just assume anything about that yet. I also don't even know what it is. Is it a relay? Because I've got in12 power. Morning, welcome to the stream. We're looking at our AC distribution on our Merlin right now, figuring out what's going on in this email box. And I want to be kind of thorough on this email box because I can tell that things have happened to it, to put it mildly. And there's some questionable contacts, and why is this all sticky? I don't know why this is sticky. That's fun. Well, okay, that's not that loose. We'll check. We gotta check torque on all these too. Is that? Why does this one? This one might not be on the DIN rail all the way. I don't know. Okay. Let's get the multimeter out. That's going to be easier to verify some of these wires than doing it visually. Let's see here. I was using the multimeter last on one of my broken studio lights. So let's go grab that. So I had one of my studio lights, and the one of the encoders wasn't working. Like it was, and it wouldn't let me adjust the color temperature or what color of light it was making. And I didn't like that. So I took it apart, and it turned out that, so the, rotary encoder is a 3-pin device, right? And so one pin was like shorted, well, 50 ohms. It was always 50 ohms, and then when I would rotate the encoder, it would go down as low as like 0.1 ohms. So I sprayed deoxit in it. Deoxit's usually used to like improve contact resistance, but in this case, it fixed the short. So like there's clearly something going on wrong inside that encoder that like spraying deoxit in it fixed a short. So that was fun. So I'm gonna guess that K1 goes up to that, like K2 like that, right? That seems kind of reasonable to me. But we're going to verify that. We're going to give ourselves some more room to work with here. Make our wires more squiggly, but that's fine. This is just a draft. We can deal with squiggly wires right now. So let's see if that output does go up to here. Here, we'll turn it on the mode where you can hear it beeping. Yeah, that does indeed go up there. So that probably goes up there, which it does. Okay, cool. So that's our, that looks like all of our AC, if I had to guess. That would make sense if that was all of our AC. So that's our AC flow through our emo box. So the question is, how much deeper do we want to dig into this? Let's just start connecting some wires and see where it takes us. Okay, let's see here. So some of these definitely go to this power switch. So I'm gonna, if I had to guess, So this is an illuminated power switch, it says, or it says LED on it. So the right side seems to be the switch side. And then I think the left side is just the LED. Yeah, okay. And if I'm gonna, I don't know for sure, but I'm gonna guess that that's a normally open switch. And I think that that will kind of become clear as we look into the wiring more. Okay, so let's add switch 1 up here, or S2, I guess. So how does S2 work? S2 is a, well, it's got an LED. And the LED is on X1 is our positive side. X2 is our negative side. Am I drawing that backwards? Right, probably. I am. It doesn't matter. Because actually, oh no, it's a bidirectional. It's got the circuitry in it to do it either way, is what the symbol on it says. That's why I was drawing it backwards. And then let's see here. And then below that's our switch, which we can test if it's normally open or normally closed, can't we? Oh, really? Huh. Something seems weird in this switch. I'm not getting, I'm getting like 50 ohms through this switch here. Oh, there it goes down to 5. Is that just my probes? That doesn't seem right. Because I feel like that should be lower resistance than that. Right? Wouldn't that make sense? Huh. I'm gonna write that down for later. It is indeed an NO switch, though. And that's going to be, oh, it does say, it says NO on it. I just wasn't reading because it was behind a wire. Okay, so there's going to be some kind of latching configuration going on here if I had to guess. And then I don't think this box has any wires that come out the back of it, but I can't really tell from here. So interesting. Okay, so pin 4 of this switch is connects up to that. Yeah, we'll do this. We'll do the swooping one. Then where does pin 3 come from? Pin 3 goes over here to S33. So I probably should change these labels out to what they actually are. So that's going to be A1, S34, S33, and S11. And then this is going to be S12, S21, S. Okay, so then the other side of this switch, which is 3, goes to S33. Yep, I don't know what S33 does yet. So where does this lower side here go? I feel like that goes to the negative rail of our power supply. Positive rail of our power supply. Well, those are NC, so it's hard to say where that actually goes. What? Okay, why am I getting... I'm getting 200 ohms, which I feel like that shouldn't be 200 ohms. I feel like that should have been 0. Okay, let's get out a couple of foam pads because one of my legs is already falling asleep from how I'm sitting on the ground here. Okay. So I'm measuring from, somewhere we have a good hanger for this thing so that you all could see the resistance. Yeah, that's gonna be hard. So across what is labeled as a normally closed, Are my probes okay? Yeah, my probes are okay. So why am I getting... Okay, so I'm going across what's labeled as normally closed, and I'm getting resistance measurements all over the place, like 200 ohms, 400 ohms, and it's jumping around. But when I push it in, it goes down to open circuit. So I don't know why that's doing that. Glare's making that hard to read. So you see it's kind of going all over the place. And then when I push it in, it goes open. So I don't... And it seems like it's changing with cycles too. So that's fun. So that's something else to look into. I'm getting very suspicious that I've now measured 2 switches in a row that I've gotten unexpected resistance values from. Why am I getting, so it's the so inside of these, there appears to, or I believe, there's a normally closed contactor right there. And it goes open circuit when I push it in, but it's like 200 or 300 ohms between these 2 points. Yeah, we'll just cycle it a bunch of times. And now check our contact, or now check our resistances. And I'm gonna go up to here. So when so I'm verifying that like I'm getting good contact with the wire. So when I go up to like where that touches the switch, where I follow this NC wire up to between NC and pin 4, between NC top K1 and pin 4 on S2, and I'm getting 0.00 or 0.05 ohms, 0.1 ohms. So I'm getting like good continuity there. But when I go to measure at the bottom of it, well, now I'm getting all over the place. I'm like 300 ohms, 400 ohms, 300 ohms, 400 ohms. Okay, so let's find where this bottom wire goes and then go to the other side of that wire. And that'll basically make sure we're actually like touching it and getting good continuity. Okay, so what do we think this does? I bet this goes to a power supply pin. I bet this goes to a positive power supply pin. Well, continuity mode is telling me that it goes to the top of the other NC contact. Illumination in a switch. So these are, I mean, there's no illumination, I don't think, on these. There is a snubber circuit on the so there is a diagram on here for these contacts. And that's for the plus minus contacts. It is what the diagram shows. Okay, yeah. So according to continuity mode, this does this. And so when I go between the bottom of this, so the NC and the other NC, I'm getting good continuity, 0.05 ohms. When I go across the switch, across the NC, I'm at 400, 500, 400, 500. So that seems wrong. So when I measure like there to there, I'm getting just random values between 2 and 500 ohms. And I'm getting the same thing, 200, 270, 250, 310, 220, 205, 216, 219, 230, 250. So this is on the K2 NC circuit. We're also getting some suboptimal resistance values. So where does this go from here? Does that go to the switch? No, does that go to the power supply finally? Okay, that goes to S34 here. That's interesting. Okay, so now let's find out what controls our coils. What do we think controller coils? Are these connected together? Yeah, those are. Are those connected together? Those are. Is that connected to this? Yep. So all these plus and minuses are all connected together, so that makes that easy. Okay, so that one comes from 24 to there. This is not a 24-volt DC supply. So this goes to 14. Yep, that goes to 14. Where does the bottom of this go? Huh. Was I touching it? Maybe I wasn't touching it. Is that a red wire? Okay, so when it's telling me that it goes to S21 here, but S21 goes out somewhere else in the microscope via this little cable right here. So I'm guessing that that goes to the email button on the front of the microscope. Guessing that goes to this button right here. So let's push the emo in. Let's see if we still got continuity there. We do still have continuity there. Well, I thought that was going to be it. Why do I feel like the emo has momentary and non-momentary contacts? Okay, no change there. So why does the red wire that goes out somewhere else in the microscope have continuity to this thing? Okay, there's a plug. It goes down to a plug right here. Let's see where that plug goes. Okay, that plug goes to a cable, that cable. Goes to the emo button. So if I unplug this cable, let's see what happens. See if that goes open circuit now. It has to go open circuit because the red wire goes straight to that plug. Nope, did not go open circuit. How on earth did unplugging it not make that go open circuit unless it's going somewhere or it's connected somehow through there? And that's like a normally closed contact through there. Interesting. Okay, let's find out what this device is. So this is a PSR ESM4. Yeah, email button, right? Okay, so this is what we're looking at. Safety relay to emergency stop and safety door monitoring up to SIL 3 or category 4. Wasn't that helpful? What did I get on my screen? Interesting. Okay, so that's what we're looking at here. So let's just, why is there multiple drawings? Are these just different ways of using it? I think they're just different ways of using it. Yeah, these are just different ways of using it. Okay, so we'll just grab that. Come on, screenshot, please. Nope, that just keeps doing weird things. Okay, we'll do screenshot the old-fashioned way. Bring that screenshot in. Okay. Turn off rotate. So that's what A2 is. So this is this. So this thing on the end here, that's our emo box. Made great progress. Okay, so we've got a reset button. S33, S34 is logic. So that's A. So A is our reset button. B is back to the browser. I love that it just says logic. For automatic activation, bridge S33, S35. So S21, S22, S11, S12 are emo circuit pairs. S21, S22, S11, S12. Those are all used. And, okay. Okay. This is making sense now. Well, almost. So this went to what? That went to 34, I think? 33? No, that went down here, right? That went to 14. So what's 14? So 14 is a normally open relay contact. So 14 and 13 are a pair. So we can draw that in. '23, 24 are a pair. I'm going to go ahead and color code this differently. I don't really have a color code going for this drawing, per se. I may kind of do, but... Where does 13 come from? I bet 13 comes from a power supply for some reason. Yeah, 13 comes from the positive rail of the power supply. I don't know what pin, but... So then that negative output, where do we think that we think I bet that negative output goes to the, or I bet this goes to the negative side of the power supply? It does go to the negative side of the power supply. Look, things are starting to make sense. That's confusing at both of those yellow. Well, it's fine. They both, I mean, conceptually, they kind of do the same thing, you know? Okay, so that's how our first relay there is. So that's how K1 is controlled. So let's see how K2 is controlled. So K2 goes to 24. Look at all the pretty colors. What color do we want to use? Vote in the chat what color you want. But I'm actually just going to probably choose something faster than that. We'll do that blue. That looks good. So if I had to guess, 23 is going to go to our positive rail here. Which it does. We'll go around the outside for that. And then if I had to guess, the negative rail goes to the negative rail. Look at that. Okay, so now we know how our... Okay, at this point we pretty much know how our contactors are controlled, and they're all controlled by Magic Emo Box. We're going to label this Magic Emo Box. The model on this is a PSR ESM4. Cool, look at that. Emergency off, because they got depressed. Okay, emergency manual override or emergency off. Sense gasp. Well, hey, I did kind of choose cyan. I don't know if you said cyan before I chose cyan or after I chose cyan, but... Okay. So then, as far as I can tell, I mean, we haven't determined how the LED is illuminated yet. Let's go ahead and determine how the LED is illuminated just because I want to know what the LED means, you know? I like knowing what lights mean. Okay, so the positive side of the LED is connected to... Let's just do another color. Why not? So that's the positive side of the LED, goes to the same contact that gets closed by the emo box on our output. So does the negative side also have 2 pins? And that goes to the negative side. I don't know how. Well, oh, probably because that is connected to there. Yeah, okay. So the LED is illuminated by 24 volts when the email controller closes the 24-23 pair. So 31, 32 are not connected to anything. Let's mark what's not connected just so we have that. So those are not connected to anything. Okay, so it looks like outputs on the bottom, inputs on the top. Did I just miss an A when I wrote that? I guess I did. What was I doing? Come on. Okay, so that's what's going on in our email controller. Ah, excellent. I'm glad I chose the color that you wanted, even though I didn't read that that was the color that you wanted. Okay, so this is no longer a mystery email box. I feel like I've got a pretty good sense of what's going on in this email box. However, it's I don't like it currently. I don't like that the NC contacts on K1, K2 are appearing to be in such poor condition. Let's see what our contact resistance is on our main contactors too. Getting 0.09. Wiggling it around some. I'm getting like 0.2. It's going down to It's going down lower though. Okay, am I just not touching it right? What's going on? .07, okay, I like that. 0.07. 0.07. Okay, so it looks like we've got the NC lines are used. The NC lines are set up so that it disables switch 2. It makes it so that switch 2 doesn't do anything when either of the contacts is already pulled in. I think the reason for that, if I had to guess, is that if something happens, it's basically so that if the emo is commanding, like if the emo's been tripped, well, why is that? Basically, you can't start it if this basically, it makes it so that you can't push that button while either of these contactors is pulled in. So before you've pushed that button, neither of those contactors is going to be pulled in. So this contactor here is, or sorry, not this contactor. This power supply is on when the microscope gets power, unless these breakers are tripped. These breakers are funny. They're red when they're on and green when they're off. I guess green for safety. That feels like a Phillips thing to do, to make the colors like logically reversed from what you would expect. Cool. Well, I'm pretty happy with this drawing of what's going on in here. I guess what I haven't drawn, and I guess we can maybe add on. We'll just add one plug on, because I think they're all identical. They're just all daisy chained. Oh, interesting. Why did I have to say that? Well, okay, I see what's going on. This makes sense. I think it makes sense. So basically, this is wired in the double redundant style. So S21, S22 is one pair. So S21, S22 is emo pair 1. And S11, S12 is emo pair 2. And that pretty much goes everywhere. So right now, do I have continuity S21, S22? No continuity S21, S22, but that's because I think I left the emo up front. I either left the emo up front, pushed in, which I did. I also might have left a cable unplugged, so let me check that. Yep, that's an emo pair. Okay, and then the other emo pair is, what did I say? S11, S12. Yep. Okay. So those are closed. So the beeping should go away. Oh, sorry about that. So the beeping should go away when I push that in, which it does. Okay, cool. So the emo circuit appears to work. Love that for us. So A1 and A2, if I had to guess, are the DC power supply inputs. We can wire that up real quick. That's probably a good idea. Yeah, A1, A2 are the DC power supply. So let's go ahead and add those wires in. So A1 is positive. New color, new color, new color. One of these purples looks good. And then A2 is going to be negative, if I had to guess, which it is. That's almost the same color as I chose last time, but that's fine. Okay, so that's the emo AC unit. So we've identified some issues in here. Yeah, this microscope was shipped overseas. That is a interesting thought for sure. Yeah, built-in inrush protection. I wouldn't expect built-in inrush protection to be so variable. You know, it's like I've just like seen the values like go all over the place. So these contacts are like never switching very much current. Like if we look at, so it's the NC contacts here and there and there and there, right? So like if S2 here isn't closed, it's not going to do anything. Or I mean, there's not going to be any power flowing through them, like when they're switching. Well, I guess if you hold S2 down, then they open. But like, so if basically if these go like open circuit, it's S2 is going to stop working. You're going to wonder why the microscope doesn't turn on. So that's interesting. So like I've cycled them a number of times, you know. I'll keep cycling. Because they're never going to cycle unless you keep S2 pushed in. They're never going to close under load. They're going to open under a tiny load. Okay, let's see what that contact resistance is now. Yeah, still all over the place. It's going down as low as 150. So I put my meter into the low ohm range. So the low ohm range runs a lot more voltage through, so that it can be much more sensitive. So I'll make and break these contacts a few times under the low ohm range and see if that improves things. So the low ohm range is reading differently than the high ohm range. So it's reading 30 ohms, and the regular ohm range is reading 140 ohms. So that definitely tells me that there's like there's an oxide issue. Like however this thing's conducting, or whatever's causing it to not conduct is sensitive to the amount of current flowing through it. So that lines up with higher than desired contact resistance, which isn't optimal, but it also is, if you know what I mean. So yeah, let's see here. I mean, we could spray some deoxide in it, but let me get a flashlight so I can kind of get a better look inside a part of this. Okay, flashlight that I want, it's gonna be on my tool cart, I think. Unless, of course, I was using, oh, there's a flashlight. Yeah, it's more of a thing if it has the potential to be an issue, I just want to take care of it now while the microscope is like in my shop, because this microscope will be leaving my shop and going to its forever home. And I don't want it to become an issue in its forever home. not immediately seeing a great way to get deoxit right where I want it. Although there is a hole on the side. That's probably a screw hole. Oh hey, I can kind of see down the crack here. Oh, I actually do have line of sight to it. Yeah, I actually can see the, I think I can see just the edge of the contact. We're gonna spritz some deoxit down there. Okay. Let's move the iPad out of the way. I'll go right where I could kind of see it. Okay, 2 short little bursts. It's already reading lower than it was before. So now in the regular resistance mode, on this one I'm down at 90. Oh, that made it worse. Now I'm in the kilo ohm range. There's crud in here. Let me go to the low range. Low range is reading 30. So I am on the second one now. So now in the low range, I'm down at 19, 18, 17. It's dropping. That's funny. Oh, now I'm in the 50 ohm range in the high range. So we're getting better as we cycle it now that we've got something in that's actually cleaning it up. Oh, I like your idea about opening it and spraying it. Let's do that now. You know, everywhere I see duct tape is all relating to the circuit that we're seeing high resistance in. Isn't that interesting? Isn't that interesting? Now that got me up in the kilo ohm range now. like 100 kilo ohms, 200, 300 kilo ohms. This stuff should just, if it's working properly, it's going to just be low resistance immediately. I've done pretty extensive testing with this stuff. I don't think we're getting good cleaning action. I think we're getting just enough in there to like move the crud around a little bit, but not enough to actually like clean it off. And I really want to get it like cleaned off, you know? Okay, we need to pull these out so we can actually get some cleaner in there. So I think that starting issues has been an issue before because all the duct tape I see, all the contacts that aren't made very well, all of that is on like this circuit, you know? I think they swapped that, and the duct tape is in multiple places. And so I think that this relay was swapped eventually, and that this switch was also swapped at the same time. I do have a burnishing kit, so I think that, so this switch was swapped, this relay was swapped, and it's probably not because the LED is burned out, it's probably because of what we are finding. And then the other thing is that this is the control inputs on this. Let me check the data sheet, but I bet the data sheet's gonna tell us that these control inputs are very, very low current flow. Nominal input voltage at UN, so that's our input. 24 input voltage range in reference to UN at 0.5. Typical input current 140 AC, 65 DC. Voltage input start feedback 24. Typical response time 20. Release time 45 milliseconds. 10 milliseconds to the 2-channel release. Concurrence input, infinite recovery time 1 second. Max permissible overall conductor resistance approximately 50. So max permissible overall conductor resistance, we're a little bit high on that actually right now. And then everything else is output specs. So there's nothing that actually tells me what my input, yeah, nothing tells me what my input, like, oh, they're opto isolators. Well, in 1-2, in 1-2 is an opto, but there is no 1 or 2. So I think the input current's really low on this. So I think that we have stumbled into a reason this thing, or I think it is possible that we have stumbled into a reason this thing has failed before. And we did it just by looking closely at it. So if I want these relays to come out, how awful is that going to be to do from the front here? Well, I see how I could pop the whole DIN rail out. The wires are not very long to allow that to happen. What do you think, Cha? Are we cooked? Well, the only wires that aren't long enough are these ones on these glands, and I can like move those actually. I just loosen these. I can just feed these through. Okay, I can just feed those through. And I can get to, it appears I can get to the 4 Phillips head screws that are holding this whole thing in. So I think we're going to pull this. Oh boy, is this going to be fun to put back in later. No, it's not long enough. No. Yes, it is. Okay, we got all 4 screws out. Let's get a screw container going. Gotta go find a screw container for this thing. That looks like a good screw container. Where are screwdrivers? How about screw container now? Just ignore the label. It's fine. It's fine. Everything's fine. So now we should be able to, yeah, that does feel loose. So if I feed these wires through, I think I'll be able to get this to pivot up maybe. Not really sure how this is gonna go. These wires are tight too. Oh, I can tell these have been reclamped before. This has been done before. I am not the first person to push these wires through like this. In fact, it used to be clamped down here, it looks like, based on the wire positions. Or where the... Yeah, okay. Oh, this thing's fun to get out. Okay, note to self, don't build enclosures like this, because this is not fun. I love, like, forensically identifying service histories. Isn't that great? Oh, look at that. It's just taped, it's just taped together. It's just taped together. That's great. Okay, so this thing's held together by duct tape. Yay! I mean, it's for cable management. Like, I get why, kind of. Oh, hey, look, there's a broken part of the power supply, too. Little plastic piece. Oh, I got the duct tape goo on my hands. Oh, that's where the goo came from. It's duct tape goo. This is all making sense now. And of course it's like duct tape goo because this box doesn't have any cooling, so I think it gets a little bit warm in here. So they did not just use the duct tape for cable labels. The duct tape was also used for everything. Oh, look at the back there. That's really got the goo on it. Doesn't smell very electronics failure-y, but I'm judging them for how the zip ties are cut, because that's sharp. That's very sharp. It's gonna cut me. I'm gonna get my flush cutters and fix that before I cut myself on it. I mean, lacing is, yeah, you're right. Like, I know there's reasons lacing is better. Zip ties are great. They're fast, they're convenient. But if you cut them like this, you're gonna cut somebody else. So that's why I am finding flush cutters right now, so that I can cut these flush and not cut myself anymore. Okay, let me scroll through chat real quick. See if I've missed anything. Adhesive deposition on the contacts, maybe. Okay, that's an interesting idea. Given that we are seeing like adhesive goo on the back of this enclosure, and all this does is just get warm. I like to be nice to the next person. Something tells me these are factory zip ties, maybe. I don't know. Okay, let's see about popping one of these contactors off. Oh God. Oh, this is we're taking this out. Oh boy. It's like, oh, what is going on? Look at this shit. You see how shiny that is? That's all like goo and liquid. Like it's so much liquid on this. I don't like whatever tape they use. This is disgusting. And it's all over the cables too. So that liquid on the back of the box, that's like was on the cables. I'm trying to get you all a good shot of what's going on the cables. Let's move you to the side here. And bring that light up and over. I don't know if you can tell how much goo there is, but like look at all the goo on that cable there. That's all goo. That's all tape goo. Yeah, I don't want this on my hands. This is gross. Filing this under glad I checked. Come on. I'm just contemplating my existence for a second before I get started on this. This all makes sense. Yeah, I'm not touching the wires until I glove up. Okay, I'm gonna have to go grab a new box of gloves real quick, I think. I will be back in like a minute or two. Gloves were not, there's some, oh, those are the wrong size. Gloves are not immediately where I thought they were. Well, there was a box there, it's just an empty box. Was I silly? Do I actually have, I have one in this box. No, there was two. Okay, we're good. Okay, let's grab some microfibers. What do we want to clean this off with? We'll start with just ethanol. Hi, I'm back. We're gonna start with just ethanol, see how that does. And then if that doesn't work, we'll maybe throw some Windex at it. See how we're feeling after just the ethanol. We're got a small bottle of ethanol. I feel like we're gonna need more ethanol than that though. And for lab use only. "95% ethanol, doesn't leave residue behind, good for cleaning microscope optics." Well, I guess optical and electron. This is gonna spike my VOC meter. It's funny how much it does. But yep, that's our for lab. That's our cleaning solvent of choice. Everclear is what it is. So Everclear is 95% ethanol. So that is a little bit stronger than most vodkas. And it used to be pretty cheap in Oregon, not as much anymore. Okay. Very small stream I have going, like very small stream. But that's because this bottle is intended for more precision cleaning applications than the amount of gunk we're taking off right now. But oh, this feels real bad. Oh, I can see the. Oh, I don't like this. Oh, the ethanol's taking it off really easy, so that's good. It feels so bad. It feels so bad. That's so funny. You just see the adhesive kind of sticking to the rag a little bit. This is great. I want more ethanol in this rag than I got. Just gonna pour it on. Well, now this makes me want to pull the rest of the duct tape or whatever this is off those wires, because those are also going to be sources of volatiles. Huh, the other chunk of residue that was like this came off pretty easy. This one is not. But I think that once I've wiped this off enough, it doesn't feel good. Okay, I want it off. It's coming off, I think. Yeah, it's coming off. There we go. Yeah, Everclear is basically the only solvent I use now. I used to be all about acetone ethanol cleaning, or well, acetone isopropanol cleaning. But I don't like acetone. I don't like being around it very much, and you definitely breathe it in when you're using it. And it also goes to your gloves. Very few nitrile gloves are resistant to acetone. Thank you for joining, Peter. It was just great having you by. I'm gonna have so much fun cleaning up all this goo, and yeah, you have a lovely rest of your day. Okay, there we go. That's looking a lot better now. Let's go back to wiping down these wires. So how could we increase the amount of current that these contacts are breaking or making? Do we want to do that? I mean, the deoxit being on there will help prevent them from oxidizing again in the future. But let's think about how we can keep this from happening again. And the deoxit might be the solution to that. And this one's really got some goop on it. There it goes. Okay, let's see if we can shift this around a bit such that we can get to the back wall here that's covered in goop. The back of this enclosure is also pretty covered in all this. Where'd that piece of tape go? Get a picture of that. I also... Oh, damn it. I got it all over my floor. Oh, this is so gooey. Well, look at that. Isn't that great? It's not coming across on camera how thick it is. I don't think. That's lovely. Love that for us so much. So where it was like taped down to the metal, like that is pretty dry. It's where it was exposed to air or exposed to like the jackets of this tubing that it's real gooey. Okay, this is going to be deposited directly into the trash so that I don't get it on my floor anymore. Okay, to the trash. And then this little green piece of plastic is broken off here. So a green piece there. So that came from the 24-volt power supply. We'll evaluate how critical that piece appears. Okay, can I get to everywhere there's goop? Let's find out. Let's throw our nozzle back on this so I can really spray the ethanol all the way back up in there. Okay, we're getting a lot of this out. Okay, how are we gonna get it? Let me grab like a wooden skewer. I think that's gonna help me get it all the way back in there. Let's see here. There they are. So I got a pointy skewer and my microfiber. So that should help me kind of clean around some of these like grooves and stuff. Oh, that worked great. Wow, that's working way better than I thought it was going to. Okay, cool. So we want there to be, I think we want this thing to be breaking, well, I don't know. Like, do we want there to be more current flowing? What help? That might not ultimately help. Right? Chopsticks are, it's amazing how useful chopsticks are. These are not chopsticks, these are skewers for a shish kebab. Okay, I would touch this without gloves now. Great progress. Okay, I'm gonna throw some pictures of this in some of the Discords real quick. Okay. Oh, I gotta go hit the button. Hi, maybe, there we go. I appreciate this convenient handle here to pull myself up by. I think that's an okay choice. It's pretty solid. Okay. Let's pull one of the contactors out and see if we can't get better access to clean it out. So that looks like the carefully lift up on that. Maybe a skewer will be enough to do it. Nope, that just broke that. Okay, we need a different shaped screwdriver. Something on the bottom? So I push down. Okay, oh. Well, I did not have to pull this out to pull this contactor out, although I am glad I did pull it out. pop this off on the end here. So it turned out, okay, so contactor's loose now. Still can't really get to it. So I have a feeling we're gonna be just taking this whole thing apart just a little bit more. Okay. Does this side panel pop off maybe? So I'm trying to figure out how to get this thing open without breaking any plastic. I'm gonna very, very gently pry, because it looks like this plastic piece pops off from the side. I don't think that's gonna work. Okay, how are you held in and how are you held together? Oh, hey, look, a data plate. Love that for us. Let's get a picture of that. Okay, let's get at the date. Let's get the data plate on camera. Okay. That's zoomed in and as close as I can get focus with this lens. Oh, my lights just flickered a little bit. Interesting. So this is a, well, I got it from the front. Phase, one phase. Maximum 40 volt to open. Is there a data plate for the others, for this normally closed side? No, there's not. Huh, okay. Yeah, let's pull the front cover off it. That should probably help. Come on, camera. Please point where I want you to. Another thing I could have done from the front, but don't regret doing from this angle. I'm gonna take these gloves off right now. I don't need these on because I cleaned up. It's not sticky and gooey anymore. It's great. Well, I do see one corner in the very back of the box that's kind of sticky and gooey still, but I can't really get to it while I have this out at this angle, so we're gonna deal with that later. Oh, interesting. You can't pull the cover off if you have the cables in. I guess that's intrinsically safe or something. But I think we can get the right-hand cover off now. I appear to be correct. It's got one tab I gotta get pushed in right there. Oh, I don't have either of them pushed in. Okay, that's annoying. What do we want to do? Do we want to pull the cables out? Yeah, let's do that. No half measures, right? Well, these were torqued. Yeah. Oh, and these fell off. I love that for us. Okay, let's tighten that back down some. Don't lose the rest of them. These the AC side contacts, which you can see now, look pretty decent. Is this all part of the same piece of plastic? Yeah, the front panel holes don't appear to have O-rings on them. Well, I can take it apart this way. Do I want to? I think so. Do I want to continue down this route I'm going down? I think this should be okay to do. Looks like it's going to definitely give me access. If not, I'm replacing this piece. Oh, yeah, that's fine to do. That worked out really well, actually. Oh, and it got me right to the contacts. Cool. So this is the bottom side. And this part that moves up and down here is the actual contactor. And I can see my 24-volt DC contacts there, so that's great. Cool, so that worked out well to split it in half like this. I'm happy with that. And I can get right where I need to clean them. So this is the coil. I think you can be able to see the coil down there. See all those windings down there, and then this is the pole piece, the part you can see from the top, and then some pins, contact pins go down through these channels here to make contact with each side of the coil. So that's actually pretty serviceable. So we're gonna set this half aside for now. And we're gonna focus on this side now. Oh, camera droop. So this is our opened up contact here, or contactor here. So the contacts that we care about it's these ones on the right here you can see. Right here, that's what we're looking at. That's our NC contact right there. So now we can hit those directly with the deoxit real easy. I might go get a different can of deoxit when it's a little bit more powerful than this one. So there's no fought that's going to come off of this. Move this contact around a bit, just to kind of. Okay, let's get this uncockeyed. Okay, let's just see what we measure now. We can go get the burnishing tools too. Well, in the normal mode, I read as low as 50 ohms there. So how do we want to proceed here? What do we think? Burnishing tool? It's going to be really hard to get in there. The spring force seems pretty weak on this. Yeah, not the strongest spring, that's for sure. Okay, let's see how we did now. .46 and dropping. Okay, there we go. That's what we want to see. Yeah, I'm just, okay. And now I can move my probes around and get that down to like 0.1. I can remove the upper half, but rubbing them around inside with the deoxide in there seemed to have worked really well. So I'm going to separate again. I'm going to see if I can find a can of deoxide that's a little bit more powerful so I can like blast out any crud that's in there. But we got that contact resistance real nice and low now. So that's good. I like that a lot. I mean, I like it a lot better than what it was, which was kind of crap. Yeah. Okay, I'm looking at how I would separate this whole thing if I wanted to. I don't think I want to. Oh, do I do this? Does this come out like this? So let's say get that out. Let's see how that's. So that's the core there. I don't like using, SSRs fail closed. Which, I mean, this technically can too, but. Let's just see how that's doing now. .19. Yeah, it still is a little bit sensitive to being moved around. So let's get, yeah, I do see how to kind of pull it out. It's just, yeah, safety rating ones are an interesting idea. Okay, I'm grabbing the burnishers and a fresh can of deoxide if I've got it, which I think I do. I don't. Well, not at least not in the bin that's supposed to be in. Oh, there it is. That one feels, this feels pretty empty. It's probably pretty low pressure. Oh yeah, that's pretty low pressure. Okay, we'll grab the burnisher. Which for the longest time was in the deoxit bin. Let's see here. Contact burnisher, where are you? I think it's in my toolbox, I think, actually. Let's see here, should be in the small electrical tools bag. That feels like it. Yeah, there we go. That's what we want. And I'm going to grab a pair of tweezers too to aid in getting the contact itself out. Yeah, locking forceps will do just fine. And we'll grab one more grab one more grabby thing just to aid in this endeavor of ours here. Oh, that has a contact sticking on the tip of it. That's funny. Oh, just in time to press the button. Okay. Well, I'm taking it out all the way. This might be a little bit fun to put back together, but that's what I've committed myself to at this point. Okay, so I'm holding it in the orientation it came out in. Oh, there's some crap. Yeah, there's certainly some crap. So that's the contact we pulled out there. Where's my burnisher? I just had it. Oh, it's right there. So that's my burnishing tool. You want to see? I'm showing you. It's right here. It's right there. Oh, that color's looking much better now. I don't know if you can see the difference in the color on the two. So the bottom one's the one that I've burnished, and the top one's the one I haven't. Give this a little bit of a wipe down too. Let me grab a fresh wipe, actually. I think I'm using a clean corner of it, but I don't like think. I want to know, you know? Where's my roll of? There they are. I mean, I could change lenses and put the macro lens on. Maybe we'll do that for the next one. Don't really know how I'm going to burnish the other side yet. That's going to be a lot more complicated to get to. I could put this under an optical microscope. I'm going to do that. I'm going to grab a picture, and then I will show you all the picture. Okay, you probably can still hear me back here. I really need to get an optical microscope set up in the front for this type of thing. And I do have a whole table of microscopes that I actually do intend to do that with. I just didn't think I would need it. Oh, it's got oil on it. Let me dab that off. Okay. I will post these pictures, but I am also going to just show you on camera right now. I mean, I have the lens right here. I could swap lenses, but... So that's the dirty one. That's the clean one. So you can see this shmoo. This is a little bit further zoomed in than the macro lens can get. So yeah. And I did already wipe it off too. Just because I had the deoxit, you know, on it. So I'm going to burnish these in the direction of the grooves, I think. Oh, it's amazing how quickly that cleaned up. Well, it's always satisfying when you can visually see what's wrong, you know? Oftentimes you don't get that lucky. Getting all of our schmoo cleaned off. So this side's good. Now the other side is not as easy to get to. So the other sides are on the right side there between those two tall pins. So right down there is the other contact. Let's look at this. How do we want to go about cleaning those up? Yeah, I can see some discoloration on those too. Solid piece of plastic there, so it's not going to come out that way real easy or anything. Oh, okay, that's progress. So I was able to get that part out the side. So that's what goes down and makes contact with the coil. So now we're just down to this part. I can see the screws, so I can see that those are not what's holding this thing together. Just pulling them out doesn't do anything. If I take this off. So if I take that off, I can get to the top of it. So that's off now. But that doesn't quite... Are those just pressed in? Let's just pull on it a little bit, see what happens. Nope. What do we think? So that that contact and that contact is what we're looking at. Gently apply some force. Wipe my tool off before I put it down in there. So we can see the contacts now. It's that and that is our other contact. What do we want to do? How do we do this easily? Does it just come this way? It is moving that way when I pull on it. Okay, the wires are coming off. Okay, we got it out. So it's easy to get, I think, the main contacts apart, or I think it's easier to get the main contacts apart than it is to get these secondary ones apart. Oh, this side's definitely a different color. So you can kind of see the on here. The right side of this. Maybe we'll get the macro lens out. So the right side of that contact is the correct color, and then the rest of it's a lot darker than it should be. And then the left side of this one's the correct color, and the rest of it's a lot darker than it should be. You can see it right there. There's like the, excuse me. Yeah, so the very extreme right side and the extreme left side of this one. So yeah, this one, yeah, you can kind of see there's some clean patches on them and then some not so clean patches. Like, that side's clean and that side's clean, but the middle's not. Okay. Okay, it does just come out when I pull on it. You just gotta kind of pull on it. There it goes. Okay, we'll put the macro lens on. I know you all want it. We're gonna do the 35 though. It's gonna be really hard to work on this under the 100 millimeter. Well, I mean, it's at 100 millimeters right now, so. We'll go maximum effort. We'll bring the 35 down here too. Okay, lens change time, get my red lines lined up. I don't have that lens cap on me. There you go. It's funny, you can see the clean area like a little bit easier when it's like defocused some. Start to see that cleaning up. Gonna let that. There we go. Nice and shiny. I'm kind of reshaping them a little bit too so that there's like more contact force on a smaller area, because we're not pushing the amount of current this thing's rated for through it. So I want higher contact pressure, and contact pressure is a force per unit area thing. So if I reduce the contact area, we increase the contact force. And one good point making contact is better than 100 really bad points. Yeah, they do feel pretty soft. Like really soft. They might be these might be carbon contacts. Okay, cool. So there's one done. Let's get the other one pulled out. There we go. The depth of field's very tiny. So here's what it looks like after just a few strokes. See, it's already a lot better. Now we're really looking good. So I'm also burnishing in the grooves. You can see the one groove I've really cleaned up compared to the other ones. That's nice and clean now. Cool, I'm gonna hit the grooves in the other one because I didn't do those yet. There we go. And then we'll do the grooves on, we'll see if we think we need the grooves on these ones. Done. Yeah, we'll hit these real quick. So this is the first one. Okay, so now we can compare the two sides. So we can see the grooves on the right one are a lot cleaner than the grooves on the left one. There we go, both sides are cleaned up now. Now there's a little bit right here I can see in the top right there. I'll clean that up a little bit more. There we go, now we're good. So what do we think? Should we assemble this with deoxit or not? I do know this does include some stuff that leaves a little bit of a film. And with how low the contact force is, that could kind of get in the way some. What do we think? Oil in there or not? I mean, as this makes and breaks, I guess we're gonna carbonize it. I think we'll leave it clean. We'll just leave it with the, how it is. I've cleaned it with the ethanol. It's pretty dang clean. Huh. Oh. My camera battery died. Well, I got one I put on the charger. So let me go and retrieve that. Okay, we lost the we lost the stream there for a sec. Because I did the thing where I clicked a window and it didn't like me doing that. Just managing my scenes a little bit and optimizing this scene for what I'm doing. Look at that aesthetically pleasing layout. There we go. Why did that stop? Oh, the TV stopped because OBS crashed. Are we back? I think we're all, I think everything's good. I think we're back there. Yeah, cool. Okay, let's swap lenses back so that we can see what we're doing easier. Because oh boy, is the depth of field small with this macro lens. But that's why I got it. Well, I mean, if I went to manual mode, cranked my ISO, stopped my aperture down, I could have had a much easier time. And I probably should have done that, but. Okay, so I got all my contacts cleaned up, I think. Yeah, they're all cleaned up, so we can start reassembling now. So that's our contact housing. I'm gonna clean this out some. So what do you think, deoxit or no deoxit? Kind of leaning towards no deoxit in this case. I brought a pair of tweezers. There they are. I bet these contacts are in better shape now than they were from the factory. Okay, let's put this stuff in. So here's a good lesson. If you're gonna be having a very low current signal relay, good idea for it to be sealed. Now that being said, having a separate sealed relay from these contacts would be maybe less safe because it's not on the literal same like actuator, you know? Okay, getting this pushed in. There we go, that one's all installed. Let's get the other one installed. There we go, they're both installed. Just gonna blow them off a little bit, just make sure there's no crud on them. Okay, got that blown off. So now we get to put our, this is our contact spring. It's not very much force, honestly. There's some force there, there's some. I'm gonna get that cleaned up with some ethanol here. Don't really know what my order of operations is gonna be to install this yet, other than don't let the spring like fly off somewhere, which I think I can manage that, probably. Oh, it almost flew off somewhere already. Doing great. Doing great. Clean my tweezers up before I use them. Okay, so we got that part in. So now I gotta get the spring into that gap right there. Without letting it fly off somewhere. Let's try that. Oh, 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 oh. So I'm going to try to put it on the top part first. There we go, we got it in. Look at that. Okay, let's measure our contact resistance. Anybody want to place any bets? Oh, 0.9. 0.09. We're looking great. Oh yeah, that feels good. And that's with the screws loose. I can get it down to 0.08 if I try. Okay, that's the best I've ever seen on it. I think we got it. I think we nailed that one. Love that for us so much. Click, 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 click. Just taking a chance to check out my other contacts as much as I can see them, which isn't the most, but well, there's some hair in there. Let's pull that hair out. I know it's fuzz. It was like, I don't know what that was. Nice. I think that we have solved that issue. So I've cycled it a bunch of times. Let's see what it's at now. .09. There we go. Okay, let's get this the rest of the way back together. So, and we're gonna also clean the parts about as we put them on. So that goes on next. And you know what's fun? We get to do this job again tomorrow. Well, not tomorrow. Maybe tomorrow. It's either going to be tomorrow or it's going to be Tuesday. I'm not sure which one yet. Let's clean up an assembly area. If I had to guess, it's probably going to end up being Tuesday when we do the other one. So this part, what do you mean the other one too? Like the other contacts, the other three? And this I should test that way I got it out. Or the other or the other contactor. I'm getting 0.13, 0.12. .12, but I'm not getting great contact from that angle. .09. .09. I'm not comfortable with poking that one in that way, but I did measure that one earlier. It's less than 0.12, so cool. So we got that part back in. Let's put the other two of these back on while we've got a chance, while it's out here like this. So these are held captive by a part that's going to go on later. But so in the interim, we're just tightening them down onto the conductors there. So that's going to hold it in place for us. So from here, I think the rest of our assembly work is going to happen inside of here. Okay, so this right here is our coil contacts. And we're going to wipe that off because that's got some schmutz on it. So these pins that stick down and out of this, these go to the coil, which is down here, right? So those pins stick through that tube there and that tube there, and those tubes go through or come up through the holes that went through the contact you just stick in. So it's like the conductors are actually going through these contacts. Kind of interesting. So we got those pins installed now. So now we're gonna get our our core installed. There we go. So that's snapped in now. So this is our coil and pull piece and spring. So these are the springs that, this is what opens it back up when it's de-energized. Now let's put that in. So you can see there's our coil contacts going into one of these slid off. Oh. So that's what one of the main contacts looks like. You'll notice it's in my hand and not in the contactor anymore. That wasn't the plan. I didn't plan to be holding this currently, but hey, we can look at it now. Cool. There's one little discolored spot, top left corner. I'm not really that worried about it. I mean, the resistance was testing great. You know, there's a lot more current flowing through this side. I'm pretty confident in its ability to make the connection, you know. So this side is just flat. Doesn't have any of that texture like the other one did. Okay, we clean that one up. I don't think we're gonna pull the rest of these. I don't think they need to be cleaned. Let's see how this gets put back in. So those actually do come out pretty easy. Oh, that's an interesting idea. Putting a switch inside the field, like a sealed hermetic one. Inside the media field of this contact. Okay, let's try this one more time. So those are, there's our, so that's where, so those pieces that are sticking out, that's what carries the current to our coil, and then these are like shields to keep our coil voltage from shorting to the contacts that we just spent all that time cleaning. So let's reassemble this. Okay, the right side's going in. I can feel the left side isn't aligned. Let me just look at that. Yeah, that should be clear. Okay, got both sides aligned. Make sure both of my springs are seating where they should. They are. I think we're good to snap this thing back together. Here, I'll move the mic so you can hear the satisfying sound of it snapping together. Oh, yeah. Isn't that great? Don't you love that clunking sound? Isn't that great? Don't you love that clunking sound? Okay, so we just got one more thing to put back on, which is the cover to this thing. So when the contacts are loose, it's this piece that like retains all that. So we'll go ahead and just insert that. Still depress that like we need to be able to. And then just put some screws in it. I love this screwdriver, it's pretty cool. So you hold the button down, and then whatever way you turn it, oh, okay, that's why you lost that camera. We'll get that one back up. Hi. So whatever way, so I hold the trigger down, right? And then it just rotates whatever direction I turn it, and it's great. I really like this screwdriver. Okay, I got that side snapped in. I think I heard everything snap together there. That was good. Cool. Okay, let's get this screw all the way in. Okay, that feels good. And that feels good, cool. So we got that back in. I'm gonna hold off on putting the rest of the wires in because we still need to do this one. But that's gonna be we're gonna do this at the start of our next stream. So I think with that, we're gonna be wrapping this up. That was fun. So we got a complete diagram of the email box done today. Found an issue with it. I think we've both addressed the root cause, which, well, I mean, it looked like this has happened before, right? Like, it seems like somebody was in here for some reason, right? So I suspect that this has been an issue before. We're still gonna take off all this other crappy tape that's everywhere, because I don't like it. I don't like it one bit. And once that's all off, get everything cleaned up in here. I think the contacts are probably cleaner now than they were from the factory, honestly. So then, yeah, we'll be good to get this thing closed back up and keep going down the chain of our AC distribution. So up next is going to be this set of breakers right here. This should be faster than everything else we've been doing. Cool. Well, if anybody's got any closing questions before I wrap the stream up, please let me know. But I think with that, we're going to go ahead and call this here and get this wrapped up. Fine. Don't even say that. Don't even say that. I mean, you can say it. I was thinking it too. I was definitely thinking it too. Well, I already found a problem with the breakers. Maybe a problem, maybe not, I don't know. So these are bus bars that are used to connect all the breakers together. And the screws on this breaker are loose. Yep. Oh my God. Okay, so, you're kidding me. The number 2 breaker, or number 3 breaker, not screwed down onto the bus bar clamp. Just wasn't screwed, just wasn't tight at all. Like they were like completely backed out. You're kidding me. So that this breaker here wasn't making good contact. Unless maybe there's some other alternative style of contact on this bus bar, but like this bus bar doesn't want to pull, does not feel like it wants to pull out unless I think unless I loosen it. Yep, nope, it was completely loose. It was completely loose. It was completely loose. Oh, you're kidding. Oh, you're kidding me. God. The line on this one is a little, L1 on that was a little bit looser than I would have liked it to be. God, that, oh my God. What? 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 That's bad. That's like actually bad. Okay. Glad we checked. Oh. I really hope this is not how this microscope's gonna be. This thing seems nice. I thought this thing was in good shape. That's bad. That's like the type of thing that causes fires bad. Oh my God. Okay. Okay, that's cool. I'm just gonna back this out just to get a picture because it's like, because I saw it. I could like see from the top. So you see how in that one, you can see the screw, and in that one, you can see the screw, and in that one, you can see the screw, and in that one, you can kind of see the screws in these ones. They were like, these were visually all the way back, like that. Yeah, you're right. You need to look at the bus bar now. You're right. You're absolutely right. You're absolutely right. Look at that. Guess what? You see the two that have marks on them? Guess what the two that have marks on them were? Oh my God. Do I see signs of like thermal deformation? Yeah, I need to clean off that side too now. Okay. Yeah, corresponding mark on that side too. God damn it. Oh man, that's deep too. Okay, we're gonna put the macro lens on for that. That's beautiful. That's art. That's oh man. It just, I mean, it was working. I have like a video of this machine like working. It wasn't working well. Like the source was like dead. Like the image was very, very faint, but it was working. And the Zeiss engineer gave it a clean bill of health. He's like, it's great, great microscope. Okay. I'm just gonna put that back in because I didn't get a good picture of how it was before, so I want to go ahead and do that real quick. Just for the illustrative purposes. I was like, maybe the bus bar is like held in by friction, you know? Damn it, that's so funny. That's so funny. Well, okay. Okay, that's fine, it's fine. Everything's fine. Let's switch to the macro lens for this. Because this got some pitting on it. It was like, it was arcing for sure. Like, what does that do? Yeah, what does this breaker do? I need to look at the panel, because like, that's gonna maybe have affected whatever the downstream device is. Check that out. And yeah. So that's what the other ones look like. That one's not burnt. It was just how it's reflecting. Yeah, 1,000-yard stare indeed. Huh. Interesting. Yep. Notice the difference in color between that one and that one. Just a little bit. Why is that one darker for some reason? I wonder why. Wonder why. So this is how the, yeah, okay, that's cool. I was like, oh, we'll start the next stream with looking at this. Nope, we're doing it now. So that's how the bus bar works. I guess this piece of plastic, it looks like could maybe be a, no, this is just a two-phase bus bar. I think. It's kind of cool. Oh, that, oh man. Look at the end of that. Look how that's cut. It just sent confetti everywhere. Oh man. Okay, well that could be a three-phase bus bar actually. Look at that cut. Amazing. Oh, you see the Sharpie mark too. Love that. I mean, it's not... would I do the same? I don't know. If I had cut enough of these, maybe. I feel like this was cut with like a hacksaw. I mean, like it's not... It doesn't matter electrically speaking. Like... I don't like how it's curved. Like it does kind of reduce the insulation path a little bit, kind of. God, that's like kind of deep. Oh, man. I was thinking bandsaw. Like, if I were to cut it, I would use my bandsaw. Oh, the end on this one's completely cracked. Oh, wow, this end's like shattered. So that's not touch safe. Ah, oh, man. Okay. So we need to take a close look at this side of the breaker too. That's cool. Love that for us. Let me see what that one does. Let's swap back to our regular lens here. Okay, let me go grab the panel that goes over this so I can see what this breaker actually did. Let's see here. Oh, you know. Oh, it's only the roughing pump. It's only the inductive load. God damn it. It's the roughing pump. Of course it's the roughing pump. Of course it's like the worst thing it could be. Well, I mean, maybe it's better than the PC. Because like that could mess with the PC, but oh, it's the roughing pump. Oh my god, so now I need to look at the roughing pump and be like, is this motor okay? Like, what was going on with the motor? Oh man. Oh, of course it was the roughing pump. Why would it have been anything but the roughing pump, you know? I have the roughing pump in here. Look at this chonkster of a pump. This thing's great. I love that it's an XDS 35. Look at this thing. Absolute unit of a pump right here. Like that's a big scroll pump, you know? That's great. The motor might not be happy right now. I bet if it were an XDS instead of an XDS, that the controller would have complained about this. Because the controllers in these are not as smart as the controllers in the NXDS, next generation XDS scroll pump. Okay. Okay. Hopefully it's okay. I mean, it was working, you know? It was working. Okay, that's, yeah. That's why we do very thorough inspections of AC distribution systems on microscopes. It's because we find insane stuff like that. Like that, I was not expecting this. I was not expecting something of this magnitude and that degree of like, god damn it. That's cool. That's great. That's just great. Okay. Yeah, once it's established the arc, it's fine, right? Okay. That was cool. Loved finding that. I'm going to wrap the stream up now. If you all have any other questions before we wrap up, you know, please throw them in the chat now or forever hold your peace. Why are we having so many weird, yeah. No, for real, for real, for real. That's exactly the type of thing that would happen. Oh my god, that's so funny. Oh, that's so funny. That's amazing. That was beautiful. That was absolutely beautiful. I loved that. I loved that so much. Okay, cool. Cool. We're doing great. We're doing great. Everything's gonna be fine. This microscope's gonna work great. This microscope's gonna be great. It's gonna be fine. Everything's gonna be fine. Yeah, the worse it is for me, the better it is for all of you, right? My misery makes good entertainment. Well, I think with that, I'm going to sign out. My iPad just fell. I've dropped it from higher. It seems fine. It seems fine. It's fine. It's okay. Everything's fine. We're gonna wrap the stream up now. That was a great end to the stream. I'm glad we found all that. I loved all that. Good night, y'all. This microscope's gonna be fine. What could possibly be wrong with this microscope? Well, that was entertaining. I enjoyed that. Did you see that? It was so bad. It was so bad. It was so bad. Okay, well. Y'all have a lovely evening. And yeah, I'll see y'all next time when we take apart the other contactor, get that all cleaned up, put it back in, fix some of those connector issues that we've noticed, and keep working our way through the AC distribution. I thought this was gonna be the last AC distribution thing, so like it's all gonna be fine. We're gonna just make a drawing of it, and then we're gonna move down and make a drawing of that part, and everything's gonna look good. And we're gonna move down some more, make a drawing of that part, and everything's gonna be fine. But nope. That's not how this is going, is it? It's not how this is going. That's fine. That's fine. It's fine. Everything's fine. It's all fine. Well, I will talk to y'all later. It was great having you, and until next time. There's the button.